question number 11, part B, angles in, well, not angles in circles, circle area, the equation of circle question. And in this question here, we're told that the tangents to C from the point T84 meet C at the points M and N, as shown in figure 4. Show that the obtuse angle MQN is given by 2.498 radians to 3 decimal places. Okay, now, so one of the things we need to know and we need to be aware of is that when you have two tangents coming from one external point to the same circle, the distance between the point where the tangent touches the circle, okay, and where the point where the tangent starts from, for both of those, must be the same length. So that length and that length must be the same. Okay, and the other thing we know is that this is QN and QM are both the same length. They're both the radius. And if I join a line between the center Q and T, like this, okay, of course that's a common length in both these two triangles. So basically what we can deduce from this is that the triangle TQM is identical, is congruent to the triangle TQN. Okay, they're exactly the same. So that means that this angle is the same as this angle. So if I find one of those angles and I double it, I've got the angle that I need. Okay, so what I need to do is I call this angle that I need to find the whole angle theta over 2. Whole angle is theta, right? This angle is theta, that's what I'm trying to find. So this part of it, I can say is theta over 2, right? Half of theta. Okay, the whole thing is theta, that's theta over 2. Now, I already know that the length of QN is the radius of the circle, which we've worked out is root 5. Okay, the radius of the circle was root 5, and we worked out the coordinates of the point Q. The coordinates of the point Q, as we found in the last question, were 3 minus 1. 3 and minus 1. Okay, so the radius was root 5. Okay, so we can use that. Now, basically what I have is I have a triangle that looks something like this. Just freehand. So 90 degrees there. Okay, this is your Q, this is your N, and this is your T, and this is your theta, this is Q, and this is your theta over 2. This is the angle I'm trying to find, theta over 2. So now, we have this triangle, QTN. We have to find this angle and double it to find the angle that we need. Okay, which is the angle MQN, which they asked us to find. Now, what do we know? Well, we know that QN is a radius, so we know that this length is root 5. Okay, and what else do we know? Well, we know the coordinates of Q are 3 minus 1. This is 3 minus 1. So I can find, okay, from this, the length of Q to T, because I know that this is the coordinates of this is 3 minus 1. And the coordinates of T are given in the question, which is 8, 4. So I'm able to find the length of QT. So I've got basically one length, I can find another length, and I have to find an angle in a right angle triangle. How do I know it's right angled? Because the tangent and the radius will always meet at right angles. The tangent and the radius always meet at right angles, okay? So I know for sure that this is a right angle triangle. So I can therefore use, trigonometry of right angle triangle, SOHCAHTOA, in order to find the angle. So what we need to do is to find the length between Q and T. Okay, now that is found using the distance formula. The distance formula is the change in the x squared, so it's going to be h minus 3 squared plus the change in the y squared, which is going to be 4 minus minus 1, 4 minus minus 1 squared. Okay, and that will give us, let me just make that a bit neater. Okay, and that will give us the length between Q and T. So I'm going to write this in an exact form first and then round it, because it tells us to round the answer. Anyway, so you're going to have the square root of, this is going to give you 8 minus, which is 5, so that's 5 squared plus, and that's again 5, 4 plus 1, 5, that's 5 squared. Okay, and that will give us the square root of 50. Okay, because we see that 5 squared is 25 plus 25, that's the square root of 50. Okay, I'll leave it in that form for now. And so I know that this is the square root of 50. Okay, now I can say that the angle I need, well, this is the angle I need, this is the hypotenuse, this is the adjacent, so I can say the cosine of theta over 2, which is half the angle I need, is equal to the adjacent over the hypotenuse, which is root 5 divided by root 50. So I can find a half of the angle I need by just using my calculator and making sure it's in, it's telling us to find the answer in radians. Okay, in radians. So I must make sure my calculator is in radian mode. At the moment, it's in degree mode. So I must set up angle unit radian 2. Okay, so now it says R, it's in radians. That's how you change this particular calculator. Different calculators are changed in different ways. Okay, so now I need to put shift of cosine, put my fraction, I've got the square root of 5 divided by the square root of 50. Okay, so square root of 50, and that gives me my angle, whoops, I have to make sure it's set up properly. Okay, which gives me my angle, which is 1.2490, 1.2490. 1.2490. I've written it to more decimal places than I need. Okay, and then you know that the angle I need is 2 times the answer, 2 times 1.2490. So the angle that we need is going to be twice that, times 2, which gives us 2.4980. 2.4980. 2.4980. Let's make sure. 2.4980. Or 09 continues like that. So to 3 decimal places, that's 2.498, exactly as we're asked to show. So the angle is 2.498, and that's in radians. Okay, that's our answer for this question done.